This task is from our Writing and Graphing Linear Inequalities unit. The lesson is Solving One-Step Inequalities. This task is taken from the ideas of Robert Kaplinski and just tailored to meet the needs in this task. So as you can see, the students are given 4 different inequalities, and the x values are there. We have the operation symbols, and we have the inequality symbol. So what we want them to do is use the integers from -9 to 9 at most once. Now, I put in each problem so they could reuse numbers between inequalities. However, I would maybe change that to be only using -9 to 9 throughout all of them. So each inequality must have a solution where the value of x is greater than 2. Now, I will tell you that I definitely had some errors and issues the first time we did this. The students were thinking that maybe they could replace x with a value. So they were thinking that they would put 2 numbers in the boxes and then they would replace x with a value as well. And so that was kind of something we had to work through and realize that we needed to be more intentional with our directions. This is an example of what one group put in their boxes. So we want to make sure and look back, and the directions say each inequality must have a solution where the value of x is greater than 2. So if we have 5 minus 2, that would simplify to 3. Is it true? Does it meet that requirement? And that does, since we can also read it as x is greater than or equal to 3. We just want to make sure whatever it is, if it was simplified down, the value of x is not equal to 2, but is greater than 2. This is an example of what students could have put in for the second inequality. We have -1 plus x is greater than or equal to 6. If that was simplified down, that would be x is greater than or equal to 7. So that would work. This next example shows one of the errors or kind of misconceptions that one of our groups had. So they plugged in 7 and -4, which on its own will work. That ends up with x is greater than 3. Now, what they were telling me during their description was that, okay, well, we have 7 plus -4, that's going to be 3. And then x could be like 4 or 5 or 6 or 7. And so they were thinking that they needed to replace the x with something instead of just seeing it as the inequality of x is greater than 3. This last one was giving a couple groups a challenge because I think they initially were just forgetting about the minus sign. So several groups put negative numbers in that first box and also used like 0 or a negative number in this box, which would not have ended up working. So we did get them to the point where they got something along the lines that you see here that does meet the rule for this task. The first part of this task has really focused on adding and subtracting in inequalities. We wanted them to kind of make connections between equations and inequalities, make sure that they are using the inequality symbols correctly and not mixing them up. This next portion is going to focus on looking at multiplying and dividing. As we know, we have that interesting rule of if we multiply or divide an inequality by a negative number, then the direction of the inequality symbol is flipped. So at the bottom of this task, you can see it says, next consider, when we multiply or divide both sides of an inequality by a negative number, the direction of the inequality is flipped. Why do you think that is? Try this with numbers. After they are given time to talk through this with their group, we pull them back together as a whole and we start to ask that question. What are your thoughts and what did your group come up with? Now, I will say this kind of gave them a little bit of a challenge and they weren't necessarily sure what to do to try this with numbers. So I prompted them with this. You have the inequality -1 is less than 2. Is that a true statement? They should get to the answer, yes, it is a true statement. But now, what happens if I multiply each side by -1? Just like we can do with a normal equation, what we do to one side, we have to do to the other. What's going to happen? We can see that multiplying -1 by -1 is going to give us 1, and multiplying 2 by -1 is going to give us -2. Is that inequality now true? we can see that it is not true. 1 is not less than -2. Therefore, we would have to switch the direction of the inequality symbol. Now consider, what if I gave you the inequality -1 is greater than -2? It is true as it stands now, but what if I asked you to divide both sides by -1? Would it be true then? So you're prompting kids to look at this just through the number sense point of view. Look at it with just numbers, no variables, and what's going to happen. They will see that when you multiply or divide a negative number, it's altering what was the largest number is now going to be the smaller. So this helps make a connection with kids so that it's not just, hey, this is a rule that you need to remember. They can actively see what is happening to these numbers when they divide or multiply by a negative number.